Good morning. Today's lecture is titled Patient Flow Analysis, PAFA. Production Flow Analysis is PFA. So Patient Flow Analysis for design of a lean hospital using production flow analysis. So PaFA or PFAST. And should we rethink the basic layout of any hospital? The reason I chose this presentation is it's a very nice application of production flow analysis outside of the manufacturing sector. You know, one would think that hospitals are service environments and that they should not be thought of as manufacturing facilities. The truth is that a group in Finland in 2007 published a paper where they effectively said we do need to look at hospitals as manufacturing systems and then analyze the way patients flow as we would analyze the way inanimate products flow. And effectively, at least judging by what the paper says, they apply the results into the design of a new acute care hospital. So I feel that there's a very strong message that we in America really need to go back and ask this question, that are we in the 21st century building hospitals still using the principles and concepts from the obsolete mass production manufacturing facilities that were obsoleted by the Toyota production system, who essentially said, let us change from a process layout to a cellular layout. So in the context of patient care, what we are saying is, can we design patient-focused facilities rather than personnel or efficiency-based facilities? So what this presentation is about, essentially three things. One is, I'd like to review what I personally think is a game-changing approach to hospital design and construction. And it was discussed in this paper, which I accidentally came across while Googling lean healthcare. And you can see that it's not a research journal, it's a trade journal, World Hospitals and Health Services. It was done in Finland in 2007, that means most recently. And effectively what they're saying is that production flow analysis, the method that is at the heart of job shop lean, can essentially be used to design a lean hospital, which I think is a very radical concept. And if you, as you see, when we go on further, the mapping between a manufacturing facility and a healthcare facility is just one-to-one, except that you cannot compromise quality in the case of healthcare. So I think safety and quality take a far more precedence over just efficiency and work in process reduction. But still, the mapping between the manufacturing flow and the patient flow is one-to-one. So what we did in this presentation is to first show that we revalidated what the authors had repeated or reported. I think that their work was probably manually done, and what they implemented was only the first stage, factory flow analysis. It doesn't really go deep into the group analysis and line analysis phases. I think that if the data is available, we can pretty much use production flow analysis and job shop lean concepts to radically change the way hospitals are designed. Of course, politics and centuries worth of traditions might be the reason why we do not entertain the ideas expressed in this paper. For that matter, I know that semiconductor facilities, what they call the fabs, they cost billions. And of course, my work is about 10 years old, but even there I have found that they were making extremely complicated manufacturing routings using essentially what is a process arrangement of the assets. There is no way that it will be cost effective and easy to control if you continue with the process layout approach when you should have cellular focus factory line approach to how work gets done. And then in addition, we've provided our own insights using the methods and software tools that we routinely execute with projects. So let me give you a quick review from Taiji Ono, the pioneer of the Toyota production system, who basically said we need to flow products, and that the 7 types of waste effectively are contributing to cost and delay in the flowing of products. So quoting again from his book, you've probably seen these quotes in the earlier lecture on essential foundation for job shop lean. But here's what is important, that he arranged the various machines in the sequence of machining processes. So the idea is that just as a product, an assembly product, has a bill of material, a bill of routings, and we should build facilities to conform the equipment arrangements with the logical flow of the product's assembly. Similarly, if you're a machine shop or a Ford shop, we need to organize the assets to conform with the flows of various families of parts. So also, what I think we can take away from this quotation is that hospitals should be designed, their assets should be arranged, their people should be trained in such a way that the way in which patients would flow typically along their care pathways, you would like the hospital and its assets to align with that care pathway. The other two quotes are not that relevant to this presentation. This one is again relevant. Toyota's main plant provides an example of a smooth production flow accomplished by rearranging the conventional machines after a thorough study of the work sequence. So in a hospital design context, I would say smooth patient flow by rearranging the assets and skills of the hospital after a thorough study of all the patient flow pathways that the hospital has to essentially fulfill efficiently. Another quotation. By setting up a flow connecting not only the final assembly line but all the processes, one reduces production lead time. So by analogy, the patient care time can only be achieved if all the delivery processes that constitute the delivery of care and the healing of a patient, they are all aligned to be in sync with each other. And this is almost like saying that if the patient is an assembled product and the assembled product is built up from components and subassemblies, so also all the value streams that essentially are required to support the patient, they should all be aligned both asset-wise and timing-wise to deliver care to the patient in the order in which their treatment probably dictates they should be treated. Finally, one last quote from his book. The first aspect of the Toyota production system means putting a flow into the manufacturing process. Now we place a lathe, a mill, and a drill in the actual sequence of the manufacturing processes. So again, instead of Toyota production system, why don't we just say healthcare delivery system, HCDS, or whatever acronym you wish to use. To put a flow into the patient care process, we need to place all the assets in the actual sequence of care. So just as we have manufacturing processes, could we potentially think in terms of patient care processes? And at least based on what these authors have reported, yes, the data exists. You know, the electronic medical records, they do exist. It is just that we have chosen not to look at patient care as we would the design of focused cellular assembly and fabrication facilities. Let me quote to you an article that recently appeared in the Wall Street Journal. In fact, the date of the article is May 10th, 2011. It says, the informed patient, hospitals overhaul ERs to reduce mistakes. Page 2 of that article says this. Among the strategies being tried by participating hospitals is a new system for triaging patients, dividing the emergency department into separate areas such as pediatrics, obstetrics, and psychiatry. And that's pretty much, by analogy, that would conform with what I have thought about is a hybrid cellular layout. So that's just food for thought. Again, this is an article which appeared in the Wall Street Journal. There are numerous other articles. Most of them have not been published in the US magazine literature. So again, that points to the fact that maybe in America, we simply aren't approaching healthcare just as we did not approach manufacturing. And Toyota came along and they scared the life out of the big three. And then today, the Toyota production system concepts, even though they've been renamed lean thinking, the production of cars as done by Toyota has become a universal standard on how manufacturing facilities should be designed and run. Why? Is it that again in Europe somebody is thinking that, hey, healthcare should also be thought of the way that the British thought of cellular manufacturing, group technology, and the Toyota folks thought of in terms of point of use cellular facilities. So, what do the authors say they make a case against patient transportation. So what they say is patient transportation, due to the layout of the hospital, is just wrong. So they offer first, transportation causes anxiety for the patient, risk of injury, delays when they should not occur, and spread of infection in the corridors and the elevators. That's the first case they make against why transportation in a functionally organized hospital is just basically wrong. Secondly, they say, transportation is basically non-value added work. There's the cost of personnel for transportation, delays occur, there are queuing issues, the 7 types of waste again. We spend so much time in time studies and simulation and looking at elevators as congestion points. Bottom line is here that transportation increases the total time taken to complete patient's treatment. And go back to one of the slides in a previous lecture, Essential Foundation for Job Shop Lean, transportation implicitly adds to the queuing cost and the working process cost. So travel, according to the authors, points to the fundamental flaw in hospital design, which effectively also points to the fundamental flaw in any manufacturing or office or organizational structure. Most of businesses essentially are functionally organized. If you read Michael Hammer's books, Re-Engineering the Corporation, he's basically pointing to the fact that when organizations are organized by function, but transactions and decisions and business flows occur across these silos, guess what? We have the same evils that we experience in manufacturing or healthcare. But the flaws in hospital design are, again, we look at departmental efficiencies, even in the hospital, exactly as we used to do in the functionally organized manufacturing facilities that the British and the Japanese transformed into cellular line part family based facilities. We essentially are paying people to do non-value added work, and then we pay humongous money in IT systems, tracking systems. Why? Because we are trying to track thousands of unique value streams in a job shop, which is basically what the hospital is, and it has a batch and queue architecture, the functional department layout. And bottom line is, that all our hospitals pretty much are comfortable being functionally organized, but now they want to be lean and safe and cost effective, but at the heart is the limitation. They're not built to do that. So here's some points which the authors make, and I'd like to give you an example of the functional layout in the next slide. But hospitals are basically organized by function. That's what the authors state. So they make the case that one, there are isolated departments, laboratories, like diagnostic laboratories, the X-ray department, operating rooms, intensive care units. Maybe there's a reason for this. Please forgive me if I'm putting too much faith in what one group of healthcare experts has said, but it would be nice to know, and I don't have information, what has happened with that particular hospital that they built. Okay, they said that in their experience, each department behaves like a functional silo, exactly as you would see in a forging company with its press department, grinding department, furnace heat treatment department, shipping department, inspection department. Again, even in the hospital, each department has its own area with similar equipment located. Why? Because they want to be efficient locally. And that one department specializes in similar processes. Unfortunately, that single process may not be enough to cure a large number of patients. And all the performance measurements, the incentivization is you maximize asset utilization in your department. Patient care, well, we'll get to that later, okay? But we all know that there are a functional organization, as is the process layout in manufacturing, has some well-known disadvantages. Long throughput times, poor control and quality of care, complicated, chaotic flow pathways, delays abound, long transfer distances between multiple departments. This too in congested downtown environments or multiple floors. And then we try to schedule a job shop. I don't know of any scheduling software that when applied to a job shop did not require a lot more extra cost to make the schedules work. So what are we trying to do? We're trying to cut healthcare cost and improve patient care by working in functional process layouts with these known disadvantages? No, not correct. So, here's an example of a process layout. You will notice that there are 3 types of equipment 11, but they're all in one area. Department 11. There are 10 types of the 3 types of Department 10, they're all in one area. Same thing with Department 7, Department 4, Department 1, Department 6, and so on. Now, let's assume that there's a patient which has to go from Department 1 to Department 4 to Department 8 to Department 9. Question: when they start in Department 1, which one of these stations or equipment will they get put on? That's the first question, right? Anyway, from here they get moved to Department 4. Again, there's a question: where do they go? Transitioning between the corridors or the floors on which these 2 departments 1 and 4 are is basically a delay causing factor, correct? Now, again, they're transitioning from Department 4 to Department 8. Again, there's this transition. That's what the authors are pointing to. And then finally, do they go to this equipment in Department 9 or do they go to this equipment in Department 9? So this is the evil of the process, the functional organization. And we're pretty much doing this in healthcare also. We're doing this in offices also. In fact, MRP systems and ERP systems are built around this fundamental assumption: efficiency, not throughput, efficiency. So, what do the authors basically say? In their paper, they come back and say, what does it mean to be a product-focused hospital, right? So we've heard of focus factories. We've heard of flexible manufacturing cells. They take those analogies and they apply that to patient care in a hospital. So what they say is, a product-focused hospital, the real product is the treated patient. We got the patient, we delivered the care we needed, when he or she needed it, at the right time, in the right place, with the right medicines and the right personnel, and we had the right result. This is exactly how we see material handling, and that's how they're viewing patient care. Then they say a product-focused hospital would basically have staff and equipment devoted to a family of illnesses. Again, I think that there's validity in what they're saying, because if you look at the OSU Medical Center, when you drive down 315 South, you see comprehensive breast care center. I'm expecting that that's a completely standalone care building for breast cancer, you know. And again, each product-focused group completes end-to-end care of the patients it receives. They don't keep spending them across floors, across departments, or on the same floor, or even maybe buildings on the hospital premises. So this may be utopian, but I just have taken to heart what these authors did, and this was just 4 years ago. The cellular organization has been proven to work, and whatever people may have against cellular organizations, whatever they may have had in the 60s and the 70s when this concept hit British manufacturing facilities, Toyota has systematically dissolved those constraints. So when people said, oh, we have monuments, Toyota came up and said right-sized equipment. When people looked at utilization, Toyota came back and said utilization is a secondary measure. Throughput and inventory reduction is a primary measure. When people talked about performance metrics and efficiency, Toyota came back and said reduce the flow time, maximize the velocity of cash flow. That's what Goldratt said. So anything, I think, personally what I think is, when people came and said, well, cells will not work, and I think the British basically went into this thought process and then retraced it, probably because of Western management concepts. Toyota fundamentally said, why do we have these constraints? They dissolved the constraints, and essentially they designed all their facilities along the concepts of point of use and focused flow. So I will show an example that with cells, you get this, you get this, you get less patient travel, lower transfer delays. This is most important, the quality of care when you focus care points. Lower inventories and carrying costs, this is what Goldratt said. And of course, improved scheduling. In many cases, you don't need scheduling software. The group itself, by sheer word of mouth, by being in cross-functional teams, by being able to do huddles of different specializations in one small area, they could be right around the patient. So why, if the manufacturing sector recognizes the beauty of cellular organization, why doesn't healthcare do that? So again, I think maybe these authors in 2007 came across something that hopefully will catch on. And there seems to be indication that there is this trend. So this is a cellular organization, you know. So once again, there are 3 patient care areas. Could be pediatrics, traumatology, cardiac, whatever. Then you can see that in the cell, the same capability is now distributed over 2 cells. Okay, let's look at this one. Capability for process 1 is also distributed between cells 1 and cell 2. Okay, then capability to deliver 10 is done here in cell 3 and again in cell 2. So this is the challenge and the opportunity that it may not be possible to design hospitals completely into such independent work units. But again, clearly if you see what's being done at the medical center, there's an Eye and Ear Care Institute. You saw the Wall Street Journal article. They're organizing emergency departments into patient-focused areas. There seems to be an opportunity, and we need to use methods like production flow analysis. Take the data of patient flows from their records, run it through algorithms like PFAST or Minitab or Arena or whatever have you, and start saying, hey, what does the data tell us? Come to think of it, look at grocery stores. They're also organized by process. But how should the different aisles be arranged with respect to each other? Look at the patient buying patterns. Look at the receipts. Take the receipts, map them into the different areas of the grocery store. There you go. You have the customer's flow pathway. Take these pathways, run them into PFAST, to a production flow analysis. Maybe the opportunity might lie for multi-product storage areas. Customers come in, they have a certain shopping pattern, they go to the area, they get what they want, and out they go. Continuing with what the paper reports, they basically said, we use production flow analysis to design a new acute care hospital. Now, I am not going to bore you with the details of the 4 stages of production flow analysis. I will simply point to quick analogs between manufacturing and production flow analysis and healthcare hospitals and production flow analysis. So, factory flow analysis. If you were to do patient flow analysis at the highest level, these individual departments could be emergency, radiology, cardiac, intensive care, whatever, and instead of these being sheet metal shop or forge shop, what you have in a factory flow analysis, and that's what these authors did, you would essentially say how many patients are swinging right across all the departments on different floors or in different buildings on the same hospital premises. So that is an analogy of factory flow analysis. Group analysis, again, here in group analysis in a manufacturing context, we had machines and we had parts, and we said each X connects a part number to a particular machine. So when we manipulated that matrix, what we got was a new grouping. Now you had duplicated and grouped various machines into cells, and each cell was capable of producing a particular family of parts. How could this be applied in a healthcare environment? Immediately you would look at these being specializations, these being patients. And when we got groups, this might be the basis for these comprehensive care centers. So just if I may be allowed to speculate, I think the hospital of the future will consist of these comprehensive care buildings, and then you'll have a smaller job shop, one building where low volume, complicated patient cases might be run through, and then appropriate job shop lean approaches would be applied, including IT, to basically say, hey, what can we do that when patients who have these complicated low volume patient care pathways, they are run into this separate building. But when you have clear-cut cases of patient care families or care lines, they go to these individual standalone centers. So this is one application of group analysis. Another would be, this was in a surgery room. When I took a tour of the medical center, just outside the surgery room, there was this a store area, and then the nurses would walk in and go picking different items for different types of surgery. So here's what you could do. These could be different types of surgery being done in that one room. These could be all the items that they require for various surgeries. And when you get these clusters, this might say, for this family of surgery, let's organize the storage areas so that when the nurses go, each rack or racks area has a clear-cut designation of items. Now, you could have the same items shared across surgeries, but through barcoding, you could aggregate the consumption of the common item across various surgery groups and then appropriately call out to vendors to supply and replenish various areas. Another application of group analysis would be, this could be, say, surgeries, and this could be instruments. So if you had to design flexible containers, then this might point to the opportunity for designing fewer containers but which are flexible, so that these surgeries which require these instruments, maybe you could design one flexible container. There's a lot of money in getting different types of containers fabricated and then managed. Who knows? Just as we have tool magazines on machining centers which can hold tools, and you have tool holders which are flexible for a variety of tools, the same concepts with production flow analysis could be applied to healthcare improvement. Line analysis, okay? So in this case, you're basically designing the layout of a machining cell or a fabrication cell. Why could we apply the same concepts to, say, a diagnostic lab? Why could we not apply that to how we configure flexible operating rooms, as opposed to how we design operating rooms which are dedicated to certain types of surgeries which are being requested with a high frequency? So mixed mode surgery rooms, I think it's possible. Let's look at tooling analysis. Again, these are manufactured parts. So I'm not saying that patients look like this, but think about, just as we looked at a machined part and we broke it up into features using group technology, and then we created what are called composite components, a single part geometry that had all the features of these parts, and that was applied to tool layout, tool groups, machine capabilities, setups, group fixtures. Similarly, why could not the same ideas be applied? This could be a patient, and this could be the different types of treatment that they get, and then by looking at how patients are operated upon using different tools, we could maybe organize the bed and the way tools are kept rapidly, so that when nurses come in, they look at the surgery and automatically they go to a vending machine in the surgery room, and boom, they pull out a tray, and inside the tray there are all the instruments that they will use in a particular sequence that they know the surgeon will adopt. Same concept of the composite component, that what you got here is a single imaginary component, but it has the various features to be machined based on what the real parts in the family are. They look at the sequence in which the tools were used, okay, and then they arrange the tooling appropriate to the sequence. So the thing is, here again, this could be a family of patients with certain types of surgeries being done on them. Each surgery could have its instruments aligned in the sequence, and then by using various grouping algorithms inside PFAST or other data mining software, you basically arrive at maybe the dedicated storage of instruments in certain containers. So I think the opportunities are tremendous. The point again is that production flow analysis, a method thought about by Professor Burbidge 50-60 years ago, actually has a very flexible structure. What it says is, go into any workflow system, look at the objects which are being used in the workflow system, look at all the workflow patterns, map those patterns in terms of the sequences in which those objects will be used in the workflow system, and then using appropriate additional data, including a layout of the system. Wow, you could re-engineer the workflow system. Okay, so the concepts could be applied to IT, the concepts could be applied to offices, they could be applied to furniture design, house design. All you need is all the patterns of workflow inside that system. So what did these authors do? What work did they do in their project? They used production flow analysis to simplify the patient flows between different units of a new hospital. And they even anticipated the volume growth. Pretty good. They knew that their current hospital was functionally organized. So that was the current state. And from the current state, they went to the future state. They looked at major care lines, cardiology patients, traumatology, neurology. They looked at that. Now, this is where I think maybe because they were doing things by hand and because they only used factory flow analysis and they did not do group analysis and line analysis and tooling analysis, which are all the other three stages of production flow analysis, again, they may have concealed reports. So they only reported one care line, neurology patients, okay? They only implemented one of the four phases. And I think the biggest problem that I have, they only looked at the high volume patient flow pathways. So these PRN, it means process route number. This is Burbage's term, and he takes the actual manufacturing routing, and when he maps that routing onto flows between departments, he calls that routing a process route number. So here's my problem. I don't think that these authors completed the analysis, and that's why, again, in being truthful to them, what they did, I'm just reporting what they essentially are doing, a Pareto analysis, which I think all lean thinkers do. They go into a job shop, they look at the high volume products, and then they do all their magic and miracles for the high volume products. And then when the job shop says, what about the complicated low volume work I do? Oh, well, why don't we do 5S? So I think, again, these authors did not do the whole thing, and I think we are able to, and that's our niche or skill set. So they looked at several departments and they talked to the people and they tried to find out what are all the patient flows that have occurred and how do these patients get moved between various treatment departments. They did not report the remaining care lines. So they did just neurology. They should have done cardiology, traumatology, surgery and non-surgical treatment. They didn't report the work for those care lines. But you know, they used from-to charts. And with those from-to charts for those 5 care lines, they created the total flow network for the hospital. I think there are disadvantages of using the from-to chart to do cellular focus factor design, but again, let me not nitpick on what I think is supremely good, excellent thinking by people outside of the manufacturing sector. And what they did was they designed the final layer of the hospital as per the principles of patient flow. So just amazing work. I'm very impressed. So what did they do? Simple things, you know, they decided the future hospital's layout based on quantitative analysis. I don't like what they did, but still, at least they did that. They looked at least a sample of the most dominant high volume patient flow pathways. Question is, what did they do with the remaining 13? I think that's important, that, you know, take the case of a job shop. They get low volume work, but they have good margins. So if they're efficient on low volume work, they're also profitable. If they're not efficient on the low volume work, then they lose money. You know, same thing with hospitals. Okay, so they design the facility for high volume patient care. They make a lot of money out of that, but it is that one complicated patient care pathway, and if that response time is complicated, if the quality of care is complicated and compromised by the fact that the patient has to be moved around too much, or resources from too many disparate separate areas of the hospital has to be moved for the patient, and that patient dies, guess what happens to the hospital? They get sued. So I think that that's the important thing, that job shop lean is saying, look, a hospital is also a job shop. Just as the machine shop has at least 2 businesses, high volume, low variety work, low volume, high variety work, but the hospital also is a healthcare job shop. Why are you designing a hospital to be in a single mode, high volume, low variety patient care, when you also need to be flexible for the low volume, high complexity patient care? You know, they concluded that emergency needed their own X-ray. Duh, yes, of course, you know. They also merged certain departments, okay? They placed two departments next to each other in the new layout. Fundamentally, what I find fascinating and admirable is that, you know what, people who were not industrial engineers, they actually did quantitative analysis and based their improvement on quantitative reports. So here's what is to be analyzed, that they looked at only neurology. So again, this is table 1 in the original paper that you will find in your course packet. So these are all the departments. Basically, you've got K is what they call home. They basically combine arrival and departure. But these were all the departments that their patients went through. The stroke unit, intensive monitoring, cardiology, you know, this is basically a description of all the departments. What they did was, even though they began with these departments in the hospital, the new hospital, they split these departments, they combined certain departments. And this is what is fundamentally different in the way we keep building hospitals in the US of A. We just take the same departments and we just put them back in the new hospital. These people decentralized and combined and made hybrid departments. And that's basically what production flow analysis in all 4 stages helps you to do. And the benefit is that you get the 7 types of waste whacked out because you're going towards cellular systems of manufacturing. So here's what are the different patient care pathways. So these are called process route numbers. But look, what they're doing is they've basically picked up all the high volume patient flows. So look at this one. 1,200 patients basically followed this route. They came from home, they went into emergency, that's Department P, then they were moved to radiology, sent back to emergency, then they went to the neurology ward, and from there they were shipped home, right? 1,200 of them. Let's look at this one. In and out. They came into emergency, got treated, they got cured, they went back home. Okay? Look at this one. They came from home, they went to emergency, radiology, emergency, then they were sent out to Department E, which is intensified monitoring. From there they went to Department Q, neurology, and they went back home. Look at what was missed out. All these complicated, low volume patient pathways. Okay? Look at the amount of backtracking you have. So in a process layout, this is exactly what you're going to get. So let's take patient route number 10. Here's how basically these patients, just 167 moved. Okay, they came from home, they went to emergency, radiology, emergency, then they were moved to the stroke unit, then they came back to X-ray, radiology, then they went to stroke unit again, then they went to ultrasound, maybe for the heart again, then they went to stroke unit, then ultrasound, back to stroke unit, and then back home. How much backtracking? God knows how much time it took them to move these patients and to give them the care. But look over here. So all the complicated patient care pathways were ignored. So yes, I mean, Pareto law is of course appropriate, but you know, if you've got patients moving around this much, or you've got equipment and personnel shuttling around between departments to patient side, that's not exactly the best way to design a hospital. And if you build it wrong, you're stuck with a stinky pig or a stinky rodent. So this was the from-to chart that the authors created. Now again, you can see that the from-to chart, this was done by hand. What FAST does is it kind of rearranges these departments, and we'll see that when we look at what we did. But maybe these numbers don't match, at least these numbers did not match between what the authors presented and what we got. But Look, the author said that they gave emergency its own radiology capability. Guess what? P is emergency and R is radiology. So in the from to chart, from to, you've got 4,500 patients totally going from emergency to radiology. And then from radiology, you've got the same 4,500 patients coming back to emergency. So it makes sense, right? I mean, 4,500, pretty much this volume is the highest in the entire matrix. Well, there's 3,500 here. But no wonder it makes sense to combine those two departments, or at least to say, you know what, we need to give emergency their own radiology capability. And what I've seen at the med centers, of course you have your hi-fi, high-tech CAT scan equipment in one department because of security and cost and maintenance issues, but you've also got these mobile X-ray equipment, right, which can be moved around on the floors. So it makes sense. Then, the second thing which the authors did was they merged stroke unit, ultrasound, and radiology. Okay, so let's look at the traffic between these three departments. So stroke unit is D. Then ultrasound is U. Okay, and radiology is P. So let's see. D to P there's nothing. D to U there's a humongous amount of traffic, 2,000, correct? Then let's look at P. P to D is 1,500. P to U is nothing. And then finally radiology. Radiology to stroke unit is 1,500 units, and then radiology to emergency is 4,500 units. So again, you can see it makes sense that they merged these three departments. So the from to chart is useful, but I think that it's just not deep enough. And if you were to do a true production flow analysis, my recommendation would be to also drill down and look at equipment inside of each department and not just look at the highest level, the functional silos, and then design the entire hospital around that. For example, when you merge these three departments, even inside that merged hybrid department, there could be individual patient care pathways, what I call flexible modules. So it's again just a bias, but you can see that when you use the from to chart, with a savvy analyst, you can reflect lean thinking and flexibility and patient care together into the design of a new hospital. Again, if you want to visualize the from to chart, this is how we do it. It's the mathematical structure is hexagonal adjacency graph. Professor Mark Hrushalics at Georgia Tech essentially came up with that term. It's essentially an extension of the idea of the planar graph in graph theory. But the idea is, again, you in a planar graph, you create these triangulations. Okay, and then what you're trying to say is that if you put departments on these bubbles and there's high traffic between adjacent bubbles in the triangulation, that's effectively saying that's what you want to do in the future layout, that you would like to put these departments either combined or next to each other. So this is just a visualization, and the thickness of the arrows represents the volume of flow. So very quickly you can see that you can take the from to chart, put it into a software package like Spiral or PlanOpt or Layopt or Storm, $75 only for Storm, and quickly you can see that if you had to design a process layout, this will be the way you do it. So again, between FAST and a package like Storm, you can do quite a bit as far as designing any physical workflow system. Okay. Now, this was the primary patient flows. You can see again that the authors have suppressed these low volume flows. Now again, yes, you get the big heavy traffic, but I think that hospitals, like any job shop I've worked with, they need to be advised that, you need to operate in two modes. One mode is, high volume, in and out patient care, short care lines, care pathways, and then you have the complicated onesie twosie. We can't go wrong, we need to be quick response. So I don't know how possible it is. in the healthcare sector, but I've seen this in any manufacturing facility. If you read trade magazines like Manufacturing Engineering, Modern Machine Shop, The Fabricator, in all sectors of manufacturing, they have gone to two-mode job shop design. And they've trained people, they've bought equipment, they've got production control appropriate to the segment of the business. So high volume, low mix, or high volume, high mix, but preferably high volume, low mix, and then low volume, high mix. It's been there. I've got dime a dozen trade journal articles that I've collected to know that hospitals also have that kind of job shop business structure in the patients they have to treat. You know, this what you see here is the typical end result, and you saw what the authors reported. This is the typical end result of a factory floor analysis. You end up merging certain departments. And this was shown in Burbage's classical paper in his book, Production Flow Analysis, and it shows up that the healthcare sector also with this group, that's how they designed the hospital. They create these hybrid departments. Okay, it's not rocket science. You have the patient flow data and you have the software reflected in the design, because if you build it right, you will do it right. You build it wrong, you will kind of get it right, you'll pay a lot to get it right. So while GE and other equipment providers are making a lot of money by going and doing spaghetti diagrams and selling monitoring software and technology, I think that if you look at the learning from the Toyota system and now these folks in Finland, what they're saying is if you simplify the system, the cost of running it and maintaining it is automatically going to be less. So there's a lesson to be learned by looking outside of our borders. So what were the benefits that the authors claimed? Either projected benefits or they knew it would happen. They basically reduced risky transfers of patients. Okay, they did, I don't know if they eliminated personnel, I don't know. But the point was, again, they had fewer indirect personnel to do all these transfers. There was teamwork because they brought together multiple skills, multiple individuals into a team environment. There was a natural boundary for each team. They were able to care end to end for certain groups of patients. And there were indirect savings, okay? Reduced delays and errors. Nurses spent more time patient side, not on transporting patients. You know, today we have reports and journal papers which talk about RFID being used to track nurse movements in large areas. Wow! Instead of putting in money into those studies, why don't you go ahead and say what were the nurses doing? You know, just through interview processes, create patient nurse flow pathways, run that into something like PFAST, and understand, hey, how could the premises, how could the floor be designed in such a way that nurses don't have to spend much time in non-value adding transportation. They eliminated all the communication between units. There was reduced usage and maintenance of elevators. So basically, you know, we pay to buy equipment for transportation and then we pay to maintain it. The message here is try and cut that down. So what were some of the game-changing ideas that these authors have to offer? Evidence, let the numbers do the talking. So they designed the new hospital not based on architectural principles and archaic manual methods like relationship charts and bubble diagrams, numerical estimates of predicted traffic volumes. They ran with the numbers. They used a well-established quantitative method, something proven, production flow analysis. They went to hybrid departments. They decentralized. They distributed what earlier would have been one location. Okay? They even looked at criteria based on numbers where they said if we have to cross-train employees, that's because these departments will be hybrid and we need the people to know each other's skills. Okay, so there was a basis for training development. Okay, and also, like we talk about the value stream manager or the cell manager, even they came up with this interesting term of a patient flow manager. You know, it's fascinating that they said, you know what, we need individuals kind of who are specialized in certain families of care pathways. If you read the Lean Dentist by Sammy Barry, a book published by the Lean Enterprise Institute, he mentioned the same innovative idea of a person that was made redundant through his lean implementations, but instead of firing that person, they made this like a patient flow manager. So he or she acted as a water strider, a multi-skilled, highly talented person who played support and flitted around, moved around various work areas in dental care cells, saying, what do you need me to bring to you? How can I support you? So, the same idea was brought in here. There's a very good case study at lean.org about a facility which went to the value stream manager concept along value stream management principles. It's beautiful to see how somebody in the healthcare sector, probably having read the literature on lean manufacturing published by lean.org, came up with the same principle. So I'm just thinking maybe the James Comprehensive Breast Care Center, maybe that's an idea of a value stream based hospital design. I don't know. So here's what we did. We just broke up the departments by arrival and departure. Okay, that just to sort of separate the routings, the patient routings. We did the good old PQ analysis, and you can see that we basically, when we sorted the PRNs by volume, you'll find that, we also picked up the same high and low volume. And again, the complicated patient care routings are low volume, and the rather simpler ones are high volume. But this is how FAST also prints out in the PQ analysis module. All the high volume routings will be listed here, and all the low volume routings will be listed here. So if you look at how, when you visualize, when FAST prints out this PQ analysis, this is the sorting done with the classic item by item sort, and this is the cumulative plot. Okay, so when you look at the aggregate quantity, so if you see here, this is about 80%. So in the aggregate quantity column, with about 80% of total flow 6,000 patients, right? About 7 of these patient care pathways account for about 82%. So here's the issue, that we are going to work with only these routings, but what about these? And that's, I think, my issue with a lot of this lean thinking applied to job shops, that they only go based on volume. God forbid, that's not the only criterion. There's volume, there's profit margin, there's total labor hours, there is value or profit, So we need to look at high mix environments and classify the work that they do on multiple criteria. And I'll discuss that later, but the method is PQRST. If P stands for products, Q stands for volume, R stands for routing, S stands for sales or profit margin, and T stands for demand stability, runners, repeaters, or strangers. We need to look at Q, R, S, and T before we decide how many businesses the job shop is trying to operate under one roof. So let's discuss this comment. I don't know if you'll agree with me, but what I said was, in the Pareto sample of 7 PRNs, except for PRN number 4, and you can see the routing in the course presentation, the lecture presentation, the remaining routings are pretty simple patient flow routes. Therefore, in order to treat patients whose routes correspond to the other 13 PRNs, which are more complex patient pathways, the same hospital layout will need to flex and operate as a quick response job shop to treat those patients equally efficiently and effectively. A process layout is simply not capable of being efficient and effective for both segments. That's the whole point, that just neurology patients, there were 2 categories. And I will firmly assert that you cannot take a hospital layout designed for high volume, low complexity patient care pathways and say that same layout and those same support systems and people are going to be able to support the low volume, complicated patient care pathways. In fact, there's a book not published by the folks at Lean Enterprise Institute, but by their sister group in Britain. And his book basically says that when he implemented Lean in a high mix environment, he actually had machines painted a different color depending on whether they were high volume, low mix value streams or low volume, high mix value streams. Even the people that were put to work in those two areas had different uniforms, and they actually had different personalities and skill sets. They said that the high volume work was given to people who did not like to do custom work in low volumes. They had a learning curve issue. And then there were people in the low volume, high mix work who had different uniforms, and they were chosen because they liked the challenge of kind of crafting new solutions and doing a high mix of work. So, wow, definitely there is a minority of people around the world, both in manufacturing and healthcare, who just are thinking the way that unLean is saying. You know what? In a high mix, low volume work environment, please try to run 2 if not 3 businesses. Now this is basically the group analysis that PFAST prints out, the PR analysis 1 and the PR analysis 2. And again, this is PR analysis 2, the dendrogram, and this is PR analysis 1. The way that these two outputs are coordinated is that the way that the patients are listed in this here is exactly how the patients will be listed here. Okay. Now, how do you read this patient treatment matrix? These are all the individual patient route numbers. These are all the various departments that they go through. So, patients in the family number 10 went through this department. You can see these departments. The next family, they were very similar, but they also required one extra. And this was department I is intensive cardiology. So you can see that if I put these departments in a group, or if I designed a comprehensive care hospital, I could take care of almost all of these patient care lines. Okay, and then you can see because they differ here and there. For example, these two patient care families, they differ from this care family by their needing to visit department N, which is intensive care unit, ICU. Okay, so if you look at this matrix, PR1 says something, PR2 says something. So this family is what is shown here. This family is what is shown here, and then this family is what is shown here. So what does this output tell me? Look at this. These are called exception operations. Why exception operations? Because between two families of patients, there's just one family that requires this particular department, T, that's monitoring. So do we need to have 2 monitoring departments? Maybe, maybe not. I don't know. That's what's called an exception operation. Because nowhere else do you see monitoring being needed by the other patient groups, right? So the question asked is, can monitoring be duplicated and co-located within other departments? So that means, could monitoring be put inside some other department here? Could monitoring be put here? And that's what, again, you see another exception operation, that in this family of 3 patient care pathways, only one requires X-ray, the other 2 don't. So again, it may be that it's not a big thing and they could easily afford a small compact X-ray equipment, I don't know. But again, that's the idea of this output. It makes you see the whole, if I may borrow from the lean.org folks. If you see this one here, this is departments N, that is cardiac care, that's N, and invasive cardiology. So ICU, intensive care, is shared by 2 families. Should that department be split up? I don't know. This group would point to the fact that you could possibly put these 2 departments in department D. So go back to the from to chart, you will see that there is traffic of patients from department D to department I and department N. And this is how you basically find out how to create hybrid departments by taking certain strongly connected sets of departments and blending them together. Look over here, same observation, that intensified monitoring is shared by 2 families of patient routes, this family and this family. So that would be the next question, that Department E is intensified monitoring. Should they essentially get their own area? Fundamentally, not having much information, I would say to basically create two separate hospitals. This would be one family, and I would merge these two families and create a second. Okay. Is this feasible? I don't know, but that's the whole idea of production flow analysis. It opens up a completely new way, flow as the basis, grouping, cellular organizations, point of views, principles which are very alien to the typical approach to building hospitals and manufacturing facilities, even organizations, that has been passed down for ages. Why? Because management has always believed in the functional approach to work and work architectures. PR analysis 3 again, it's like PR2, it is like PR analysis 2, except that now PR3 is looking at certain repeating subsets of steps. So here what you do is you look at some of the high combinations of steps, and then you can see again that this becomes another basis for saying, hey, if I took just these combinations of patient flow pathways and if I blended them together and I got like a from-to chart, could I create like a hybrid department? So the use of PR3 we haven't really explored much, but again, if we were given data from a hospital, like 1,000, 2,000 patient care lines or patient pathways, I think that we could try to come up with some hypotheses of what could be possible as far as all the possible combinations of hybrid care departments, such that patients would at least within a hybrid department not have to be moved across corridors, across elevator floors, or even buildings in some cases. This is PR4. Again, what PR4 does is it takes the exact routing of each patient and puts beneath each routing those that are very similar. So if you go down this order, you will see that one beneath the other, there are patient care lines which are very similar to the one above them and the one below them. Okay. For example, over here in this family, it's very simple, but they arrive from home, they go to emergency, they go to radiology, and then there's one thing, they go to emergency again, and then basically they go to monitoring and out the door. So it's like PR1, except that now, as much as possible, we are saying as well, if I designed a hospital like this, could I have hospitals designed as shafts? I don't know, shafts, or could they be designed as spirals? So imagine like the Pentagon has rings, or the tree has rings. Could we design inner and outer rings of hospitals so that, if patients had to cut across the emergency department, depending on how simple they were or how complicated they were, they could still go through the same department. So you might think I'm intoxicated, but I'm just saying that there are so many possibilities about looking at how organizations and buildings and furniture and machines and work areas are designed if we looked at the true routing flow. So what comes out here is very interesting. If you take this family of parts and you aggregate all the routings into a from-to chart, you will find that Q, the department Q, which is neurology, only gets flow from department D, which is stroke unit. So it's a lot easier to do pull scheduling and traffic management when you know that all your work into this department Q is going to come from department D. On the other hand, when you look at the PR4 results here for this family of parts, if you take the from-to chart for just this family of parts, that means you ran fast only for these routings as a separate analysis, and you ran fast only for these routings as a separate analysis, this becomes a lot harder. And this is where I think pull mechanisms like Polka, finite capacity scheduling, constant working process, drum buffer rope, these are far more effective than what we've been told to believe is the Toyota way to pull. So knowing the complexity of scheduling can actually be gained from just applying production flow analysis. So that's how flexible and universal is the application of Burbage's method. So you can again read these comments. What I've said here is that if you look at stroke unit D, this department is unique to the patient family 1, but, so the point is that this department is only unique to this family. But the traffic from same departments to and from this department are high, whereas the traffic from the remaining departments is low. So this mixing of patient flows could lead to problems. Quality, prioritization, injury, safety, transference of infection, God knows. So the point is that with the department architecture, especially in a healthcare setting, you could be setting yourself up for a lot of infection being transferred. Just again conjecture, check this one out also. PR 1, 2, 3, 4 essentially are the tools we use today in FAST for all the grouping analysis, the routing analysis. The from to charts are for any level of aggregate analysis, and the PQ and PQS are basically for segmenting the customers. So again, what we did, when we produced the from to chart, you'll notice that the way FAST arranged departments, it naturally brought together those departments which have a high traffic between them. So, in this area, you will see a lot of high traffic flows. In this area, since these departments are low volume, you will see that the entries of traffic between these departments are low, but there are some high traffic flows. So therefore, if you look at Department T is monitoring. What you're basically being told is, could you move this department also into this group of high traffic departments, okay? And thereby you will create like a hybrid department. But again, since there's high traffic of patient flows, you would like them to be in proximity to each other. And these departments, really the low volume, they are the best candidate for absorption into other high volume departments. Conjecture, but again, with something like FAST, you quickly get high traffic departments put together, low traffic departments put separately. So this is again the inter-business flow. So if this was high volume patient care, this was low volume patient care, this is basically, these entries are all that congestion and complexity between otherwise two businesses. Finally, just to demonstrate to you that FAST is not the only software for facilities planning as a foundation for building lean hospitals or lean manufacturing facilities or lean organization structures. We took the from to chart, the Q-type from to chart, which the authors had also produced, and we plugged that into this $75 package called Stone, okay? And this is essentially a layout which is telling you that you need to put these departments next to each other because they have high traffic between them. And you can see that whatever the block layout is, that's exactly what the spiral diagram also turns out to have, okay? So you would get this, and then based on some real world considerations, you will reflect those adjustments. So again, all that software tools do is they give the human analyst a chance to reflect their experience into a pretty good starting solution. Okay, that's what we call massaging in the industrial engineering domain. And again, if you had this, and now each of these areas had, departments had area considerations, then something like VIP plan opt or layout or spiral could easily give you the layout. The problem is, again, please note, what you're building, this is the process layout for the hospital. So, go eat your heart out. I mean, you can put all these high traffic departments next to each other. These are all corridors if you wish, but still you are transitioning between areas, between departments. These transitions don't come without a cost. They come with the cost of infection, risk, queuing congestion, patient work in process. So go ahead, buy whatever software you want, but how does it help you that with a package for facility layout, all you're doing is taking an existing process layout and designing a slightly more efficient process layout? It's still a functional layout. It's still inefficient. it's still not able to support patient care. Quick response, flexible response. So the picture may look good. The architect may be able to provide a nice blueprint to hospital administrators. Somebody at the administration level has to get up and say, hey, what is all this? It's not good for us. What's this? Not good for us. And what are you doing here? Your optimal process layout has not helped me to be quick response for the low volume patient flows. So I would like to leave you with just a simple last message that just because you have software out there, no matter how good the software is, if that software is not supporting lean thinking, job shop lean thinking, flow, patient care, quick response, forget about it. The best software is lousy software. It's garbage in, garbage out. So that is pretty much the end of my presentation on using production flow analysis to design a lean hospital. I think that paper, when you read it, you will find and you'll be amazed at how far thinking and visionary those authors were. Once I discovered the paper, once I saw that I had the data to do something with PFAST, the software we have to implement production flow analysis, we validated their work, and then we also enhanced and added to the work they did by looking at segmentation analysis, by looking at the routing, grouping analysis. That's it. Thank you very much. Have a nice day.